Hey, welcome back. So in this session, we're going to do a little bit of interactive, hands-on discussion of what it looks like to actually examine an application, a mobile application, and then Rhiannon will talk about how you actually develop an application security framework using the State Bank of Pakistan's template as an example of a use case in practice. So before I start, any questions from based on the last session? Everybody's been following along. It's good. You'll all be able to answer the quiz at the end of the session. I'll take that as a quiz. Don't worry, there's no quiz. Okay, so let's talk about what it looks like from the standpoint of assessment. What do you do when you're actually looking to analyze these applications to determine and assess their security? So there's been a lot of advice on how to actually do a security assessment. And in the presentation you just saw, I gave a number of recommendations for what you should be looking for and to assure the security of these applications. But the question is, you might be asking yourself, all of this is well and good. You've given a lot of advice, a lot of what APIs I should be using, etc. How do I actually go about assessing how to do security? So what I wanted to do for just a little bit of time was to go behind the curtain a little bit and show you what it looks like to actually assess what is going on inside of a mobile app. So there's going to be a bit of code involved, but don't worry, I will walk you through or describe what it is that you're looking at, so you'll hopefully have some idea of what you're seeing. And I'm going to focus on Android for purposes of this presentation. Also, the application that I'm looking at is an open source. It is not a DFS app because I didn't want to reverse somebody's DFS app live in front of an international audience. So I will instead give you an example of what it looks, the general examination of what an application looks like when it's been decompiled, and you can see some of the types of services, how communication is done, etc. So you can get a sense of what an assessor might actually be doing. So first question is, how do you actually assess the code for a DFS application? Now, the best possible scenario is that you are a regulator, for example, and you make your DFS provider give you the source code for the application so that you can assess it. Or you're an MNO, and your application developer, which might be in-house or might be somebody that you've contracted out will share the source code with you so that you can actually do an assessment of what is happening. Sometimes that's the case. Other times that's not. If you don't have the source code, can you still do any type of assessment on a device? Now, having the source is always best because you'll actually be able to see what's going on inside the application. What you can do as well, though, is you can do what's all called a dynamic analysis, where you look at what's happening, the operation of the application as it's running on a mobile device. So this can allow you to do things like observe how TLS certificates are negotiated. It can show you susceptibility to, for example, if you install a fake certificate into the phone, you can see whether the phone trusts that or not. If an application is using certificate pinning, then it shouldn't trust a newly installed certificate, as an example. And you can run a variety of applications that will allow you to do this dynamic analysis that will allow you to see what the information that's being transmitted back and forth between the application and the other side. And then certainly from the standpoint of what's going on the DFS server, you'll be able to see transactions as they come through. The problem with the source-based, without having the source, is that you get little direct insight into what's actually going on the inside the application. Some of the activity can be inferred because you can effectively take some guesses in terms of based on the functionality that you're observing. You can make some determinations, but without the code, you don't exactly know what's going on. The code is really the means by which you understand the application's activity. Now, the next question is, let's say I don't have the source code. Is it possible for, if all I have is the binary, if I've got, for example, I've got an Android app that I've downloaded from the Google Play Store, so I have an APK file, or I've received that from whoever my developer is. Can I actually still get access to the source code if all I have is the binary? And the answer is, perhaps surprisingly, yes. There are two things you can do. You can disassemble the code so that you can recover object and native code, and you can potentially recover the source code altogether through a process called decompilation. So there are programs out there that have been designed to take, as an example, Android applications and actually excuse me, and actually recover the source code based on the application that's been packaged and put into the Play Store. So we've used this mechanism a lot. This is also known as reverse engineering an application. And again, do reverse engineering with care. It's only under certain circumstances should you be doing it. As an academic, I can do it for research purposes. As a regulator or somebody with some authority, you can set the rules in terms of what you're allowed to look at. Now, how do you actually go about recovering the source code from an Android application? So Android apps are packaged in what are called APK files, and they've got binary code inside of them. So this is effectively unreadable by people. This object code is stored in a particular format. It's based on it's Java-like in what it does. So you write applications in the Java programming language. Sometimes they will have portions that are native code that are written in lower level programming language like C. Those cannot be fully recovered by some of these processes, but they can be disassembled by other tools. So you have open source and commercially available programs to convert these application files into intermediate representation, and the best performing ones of these will actually recover the original Java source code. Like I said, sometimes for issues of performance, some of your applications might be using a native code that are designed to run directly on the mobile platform as C code, as opposed to Java. And there are decompilers and disassemblers out there that can be used. The commercially available IDA Pro is often used by binary analysts and other reverse engineers and forensic specialists for recovering assembly code from the machine code that's been packaged into an application. And more recently, the U.S. National Security Agency, the NSA, has developed a very interesting and compelling tool called Hydra that's been very used extensively over the past year in the open source community. It is freely available for anybody to use, and it allows you to both disassemble and decompile binaries. Otherwise, if you wanted to actually recover the original code, you would need a tool such as Hexrays, which is made by the same folks that develop IDA Pro. These are fairly expensive tools. It's about $2,000 a year to get IDA Pro, and another $2,000 a year or $2,500 a year to get Hexrays. But Hydra is open source and free. So what I'm going to do now is I want to talk a little bit about what it looks like when you actually take an application and decompile it. What can you see, and what does this mean from the purposes of assessment? So let me do that actually directly from the terminal. So let me pull my. Okay. So welcome to my file system. Where am I? Okay, FIGI Clinic. Okay, so what I've done ahead of time is I've downloaded an application. You're going to see it on screen here. It's called fdroid.apk. So I went to the website fdroid.org, which is a repository of open source Android applications. So you can take one of these APKs and you can load it directly onto your mobile device. That's called side loading. So you can have this application and put it directly on your phone from fdroid. So this particular application is a wrapper for a Bitcoin service. But the important thing is what you actually do with this file. So if I was to look at what's actually happening on inside this application, this APK file, like I told you before, this is a binary file. So you're going to see a lot of stuff that looks like this. And now that is not very readable to the average person. I have some students who can probably do a good job at reading this, but they tend to be specialists. So the question is, how do I take that binary output, which doesn't really look like much of anything to me, and actually reconstruct the original source? Now, it turns out that I can do that. So I've installed a tool on my on this computer called JADX. And JADX is a free and open source tool that is designed to decompile Android binaries. So I can take that APK file. I run that program called JADX, which I just showed you. You can freely download that, JADX, and it will create a decompiled version of the Android app. So what do I mean by decompiled? Well, I've taken the liberty of already decompiling it for the purposes of this presentation. It took about 5 minutes on my on this computer to do a full decompilation, and it decompiled into this this directory after it. Actually, I'll go after it decompiled. Okay, so when I go into this directory, all of a sudden I've got all of the bits and pieces of the application, all of the libraries that were used, and as you will soon see, all of the source code that was actually used to write this application. Now, I could do this from the terminal, but for the purposes of this, I can also use a development environment, and that might be a little easier for me to show you what's going on. So I'm going to pull this over. This is IntelliJ's IDEA, which is a freely available Java compiler. I effectively made a project. Oops. Let's see if I can do this from. So I took that decompiled code and I loaded it into this IDE so that you have a good sense of what's going on. Now, one of the things that I can do when I've decompiled this application is I now have all of these directories and all of this source code. One of the first starting points I can do in order to figure out what this application is actually asking for is going to this file called the Android manifest. So the Android manifest tells you what is it that your application is actually asking to do. So you'll notice that this application that I downloaded, there are a few things looking on screen here. So the permissions that are being asked for by the application should have something to do with what's going on inside the code itself. So as you can see here, for example, the code asks for access to NFC and Bluetooth, but notice that required is false, so it doesn't need these to work, but it wants them regardless. It uses the permission, so it needs to have access to the internet. It needs access to the Wi-Fi. It needs access to a few other things. It needs access to external storage, to read and write from external storage. Now, as you might remember from what I mentioned at the tail end of the last talk, external storage can be dangerous. Why is that? Because when so external storage means, for example, if you have an SD card or someone that you put into your device that is written effectively out of the operating system. Now, the problem with external storage is, well, for one thing, it's useful because it allows you to extend the storage of your mobile device. So if you've got, say, 16 gigs of flash and you put in a 64 gig SD card, then now you've got all that additional space that you can use. So you can store like your music or your movies or whatever it is that's on there. The problem with external storage, though, is whenever you put data into external storage, it means that any application, not just the application that you would use to write out to external storage, but any other application on your mobile phone can now access that external storage. So this means that if there's a malicious application, if you've written out, for example, a transaction ledger or account information, and then another application on your phone that might be malicious can read that external storage and potentially read and eavesdrop on that information, or in the even worse case, modify that information, such that when you read it back in, you're reading in the modified data, and that can be a vulnerability. That can be a major vulnerability for your application. So this particular application does something with regards to external storage, reading and writing. So as somebody who's assessing the code, I'm going to look at that and say, why is this application asking for external storage? So what might I do? Well, I'll probably go through the code and try to find examples of where that external storage is used. So let me show you what that looks like. Fortunately, the top bar is interfering with my top bar here, so I might need to deminimize here for a little bit. Pull things this way. I'll just pull this down. Okay, so let's look for how is external data actually being used on this in this application. So I'll go and I'll try to find every example of where external data is being used. So let's find. Oops, sorry, I jumped there for a little bit. Let's try it again. Find path. Okay, so external. So I'd already written in external. I'm going to look for every example of where external is being used in this project. Now, as an assessor, I'm going to look at this and say, well, okay, what do all of these examples look like? And this should also give you some indication that, you know, doing an assessment is sort of part science and part art. You kind of you have things that you know that you're looking for, but you don't really know exactly what's going to happen in the application until you're inside of it. So you can develop a somewhat systematic means of doing assessment by looking for specific things, but once you're inside, you're going to kind of go through and see what you find. So in this example, I'll see that, you know, I have something here related to an external parser. Is that okay? Well, it turns out that this is part of org.bouncycastle. Now, that's not going to mean anything to anybody here, but Bouncy Castle, I know, is Android's implementation of TLS. So this is probably fine. So I'm not going to concern myself with looking at those. Here we have something that's clearly a library that's been loaded by the application. This has to do with faster XML, so some sort of rendering of an XML code, a data file. And again, that's probably okay. If I'm really looking to rigorously assess this code, I might want to make sure that this is at least well known. But that doesn't have anything to do directly with the main content of the code itself. So I'm going to keep looking through and come down a few bits here. There are parts that are actually somewhat more interesting. For example, not ASN, but we'll see where. Okay, uses external ID. No, that's okay as well. That's our data handler. Where did I see the example of where it's happening in the main code? Okay, there's a. No, that's Bouncy Castle again. Okay, this is okay. Right here we go. So here's an example of this is the main program, and I can tell that just by looking at the directory. This is org F-Droid. So now this is no longer an Android library or some external library. This actually has to do with the main DFS application. So I'm looking at this application, and I see I can look at the source code here, and I see that there's some activity where a file is explicitly being picked up from external storage, and I'm going to look at that and say, why is this file? What is it that this application is trying to do with this application storage? And there's a whole lot of stuff that's happening here, and I'm not going to get into the details of that. But I noticed that there's some line here that says if I have a version of Android greater than this version 21, then I'm going to go and get some external data from the files. And I'll do some sort of checking of what directories that I've received from those files, and so on and so forth. Okay, now it turns out that if the file is removable storage, then do certain things, and if not, do some other things. So essentially, look for the directory where this external storage is happening. Okay, so that's all well and good. So what do I know based on this? It means that what I know is that this application is capable then of reading from the external storage. And I've now identified in the source code exactly where this application storage is occurring. So as an assessor, I'm going to look, and what I'm going to do is I'm going to go and apply the rules that I talked about before about input validation, because I don't want this, and I'm going to look to see how is this, how are these data files being used. I'm not going to go through the chain of exactly what that looks like here, but you should hopefully have sort of the general sense of what this looks like from the assessor standpoint. So I've found this potential vulnerability. Now it's going to be my job to make sure to determine whether this really is a vulnerability or not. So how is this external storage being used? Is it being used as part of a DFS transaction? What type of data am I grabbing from external storage? Am I validating that external storage data before I actually use it? Or if I'm not validating it, then I run the risk that somebody else on the system could have modified that data. So if it turns out that, for example, this is a DFS application and I'm reading in this external data, then I could potentially be causing a vulnerability. I could be allowing a malicious adversary to eavesdrop on my data or tamper with my data. That can affect the flow of data and potentially cause them to do something like steal money out of a transaction. So those are the types of things that we look for. We take the recommendations, we find ways into the program from, say, when the program begins. We find the critical types of functionality that are happening with regards to DFS. This is often the registration routine, when transactions occur, etc. And we'll actually look to find what the data looks like. Now, you might be looking at this and saying, and remember, like I said, this was all accessible from a freely available open source application where I took that Android APK and I can now look at the source code directly from there. So you might be thinking, well, maybe I'll obfuscate my code. Obfuscation, I've looked at obfuscated code as well before. Obfuscation makes it more challenging to do, but it doesn't make it impossible. It gives you, it's a means of, instead of having a variable name, or here it's clear that something is external storage because you can see the variable name external storage. If this code was obfuscated, that would be called A1 or A2 or something like that. And same with function names. You might see a function name here like check compat self permission. In an obfuscated in a piece of obfuscated code, this would probably say something like A2.A3. So the functionality of the code is there, but it's stripped of any of this kind of identifying information, which makes it a challenge. But it's not impossible. If I'm a dedicated analyst looking to look at your code, it'll make it harder for me to do, but I can still do it. So one way or the other, you can see that certainly though being able to see the code, it's one thing to have a permission that says external storage is used. Okay, great. But being able to see the source code tells me exactly how that code's being used. And then now, as an assessor, I could say, are you doing the right types of security checks on data when these potentially vulnerable things are happening? Okay, so let me give you one more example of how you might use this in practice. I'm just going to go to the terminal to do this. So one of an important thing to look at is how are the connections being made to the remote side. And so I'm going to talk briefly here about, let's look to see what type of URLs are being used inside the application and see what it's trying to connect to. So to do this, I will just look through the source code and find any examples of where HTTP is being used. So I've ran a command here that lets me look for every instance of the term HTTP within the source code. And I should see in a couple of seconds, hopefully, all of the various files where the word HTTP is used. And again, I can go through these, and some of these are not going to be particularly problematic. For example, something that's related to Android.com is probably fine. Things where you're talking about HTTP classes is probably fine. What I care about, though, are specific URLs. So let me actually look specifically for HTTPS. So for example, we have a URL here that I don't recognize, fdroid.org/repository. I downloaded this from fdroid.org, so this is probably fine. Let's look for some other examples. Okay, so here's a couple of things these are from the main part of the app. So these aren't a library, they aren't Android code. I can tell that just by seeing that this is this for F-Droid. So you can see that this is the actual application that I downloaded. In fact, it's called app.java. And within here, I see that there's some string that's being used and the name of an HTTP connection. So there's a connection that's going to be made to this URL, flatter.com. And another one that's being made from liberapay.com. So I'm going to look at this and say, well, what do I know about liberapay? And before looking at this app, I actually didn't know anything about liberapay. So I might be asking, is this a secure connection, or can something like liberapay accept potentially insecure connectivity and potentially be putting my data at risk? So in order to assess this, there's a neat trick that we have, of which involves the use of SSL libraries, or SSL testing tools, or TLS testing tools. So remember when I talked about in the last presentation that you can choose how to negotiate with a TLS server, and so the server can make some decisions about what types of connections it's able to make. So let me show you here a tool called that we use in our research and that a number of independent assessors also use. It's from a company called Qualys, but this is freely available. The Ssl Lapse Tool allows me to type in a URL or a domain name, and the tool will actually attempt to negotiate using a variety of different cipher suites. So it'll try to negotiate using a number of different ways and see which types of methods the server actually accepts. So it's a way of testing, does the server actually allow for insecure transactions or not? Will allow an insecure transaction to be made, one that is using an older version of TLS or one that's known to be susceptible to some of the attacks that I talked about in the last presentation. So I did this. I ran this report on liberapay. It takes about 5 minutes for this to run in total, for it to go through and negotiate. It turns out that in every case, it turns out to be a very good server. It gets an A+ rating from Qualys. So Qualys will give you a report card at the end that tells you, and it's since this was an A+, nothing was found. But I've looked at sites that have gotten an F, where it'll tell you, this site allows the making of connections with an insecure version of TLS. This site is susceptible to some of the attacks that I talked about in the past. And I've actually seen this happen against real mobile money systems. So this can be a means as an assessor to make some determinations into how secure are the connections that my clients are able to make with the servers, and is it possible to make insecure connections with my server? So that's what I wanted to say about that. Now, finally, let me just say a couple of things about what this might actually look like in practice. So we've written a couple of papers in this space, and we got some notoriety from our initial assessment of the state of the mobile money ecosystem in 2015, where we found a number of security vulnerabilities in a variety of mobile money applications. And effectively, the way that we found those was by going through pretty much the same procedure that I just showed you here. Finding the APKs for those mobile money apps on the Google Play Store, downloading them, reverse engineering them, looking at the source code for the important routines, and finding major vulnerabilities in terms of how cryptography was used, how data was stored, etc. Now, more recently, we looked at digital credit. We actually published this work last year, and I wanted to show you some of the types of things that you might see. And again, since this is published, I think it's probably okay to show you it. I'm not going to name any names here or anything, but you'll see that some of the things that we found include an example of an application that uses a static string for generating keys. So in this case, not only is the insecure DES algorithm being used, but the string that's used to generate keys is the same one every time, which means you're effectively generating the same key. If you learn this string, then you can figure out a lot of things about any other key that's being used in the system. Another case here of a DES connection being made, and a company using a static string to generate the cryptographic key. So this is always a bad idea. You always want your cryptographic keys to have randomness in them, because if they're not random, then somebody can guess them, especially if they're inside the app. As you just saw, all it takes is somebody downloading the app and using one of these freely available tools to recover the source code. So I do that, I read this des string, and now if I'm using this app, I have a good sense of how the keys are being generated, and now I can decrypt a lot of stuff. And now all of these apps are potentially at risk. In this case, we see an app that's using a static cryptographic key across all of its users. It turns out that this code was actually taken from an open source project, and so this application uses the same key as that application as well. So because this key is the same one that's used across all users, it means if anybody learns the key, they now know everybody's key as well. I guess the good news is that they're using AES instead of DES, but that use of a better cipher is essentially nullified by the fact that the key is the same. So as long as I get the key from one application, I can get it across all apps. And finally, with regards to that discussion that we had about cipher suites and how to negotiate those keys, we saw in this example of an app. And again, these are real apps that we found out there, in this case being used for digital credit. This particular app allowed for the use of export DATs. That's that 40-bit encryption that effectively your smartphone is probably well enough equipped to be able to decode and run brute force attacks against. So export, DES, and triple DES, and all of these are considered weak. And you can see here that RSA, in fact, even worse. You might be using RSA, so public keys to do the negotiation, but then the session key itself is actually being done with not even DES, but null encryption. In other words, negotiate the session key in plain text. Null encryption is allowed in early versions of some of these TLS libraries. And when you're using null encryption, that means I'm using no encryption. So I can successfully make a negotiation of a server with null encryption with this particular application. That is bad news. And in this case, I'm using 40-bit DES 40 here, and an insecure hashing algorithm. So again, these are the types of things that as an assessor, I'm coming in and doing an independent assessment of the code. And you can also see here the value of having the source code, because some of this stuff I can kind of infer from how the application runs, and I can figure some stuff out. But by having access to the source, I can do a better job of assessing the quality of the source code. So as an MNO or as a regulator or as somebody in charge of overseeing the health of your DFS ecosystem, doing these types of assessments, having the capability to do these assessments, and having as much information as possible is the best possible way to assure the security of the apps that are being used, and which effectively goes to ensuring the security of your users. And if a secure user is one who has confidence in your system, the entire DFS ecosystem is based on trust, just like everything financial. If users lose trust in their applications and they lose trust in DFS, then the consequences for the viability of the ecosystem are catastrophic. So these types of things are important to do. Okay, so now you've seen some code and you get a sense of what an assessment strategy looks like. Any questions? Any questions I can take? Okay, if not, I'm going to turn it over to Rehan. Unfortunately, I have to catch a plane because I need to be in Washington. Yes.
For using your last tool, the
GHIDRA? Yes.
How do you know that it's Java 5?
Oh, that's a great question. You will a tool like so there are two types of tools. There's ones that will take your Android app and the .dex files that are associated with them and turn them directly into Java. In some cases, when you read the output of these files, they might say can't compile or can't decompile this file, and it'll give you this intermediate format. So that might be a tip-off to you that this is not Java. It's either this is not Java or I need another tool to try to use. In some cases, you'll actually see sort of .c or .o files that are representative of object files. And then you'll see that these cannot be decompiled by your Java decompiler. So you need to go to another strategy for them. So usually the first step is use a tool like JADX or one of these Dex to jar Java-based decompilers. And anything that doesn't decompile, if nothing decompiles, or when I decompile, I see that all of the functions are effectively wrapper functions to And by a wrapper function, I mean they present an API, but the functions aren't actually defined, or they're defined in a library that I can't open. That's a clue to me that that library is probably written in native code. And a lot of folks use native code for a lot of reasons, because, for example, native code runs more efficiently. So it means that, like, if I'm running something that's graphics intensive, I can get direct access to the system's APIs through native code. And in some cases, it's a way of trying to hide what the code is actually that's running in the first place, because application developers also know that you can decompile their code. So if I place the majority of my things in native code, now these tools are no longer effective. So I have to go and disassemble the files. And assembly is a lot harder to look at than source code for Java, for example. But with tools like Ghidra, I can both disassemble and then decompile those files and try to reconstruct the seed from there. So that's pretty much what I would do. Is I would try from it with a Java decompiler first. And anything that didn't work there, I would go to a tool like IDA or Ghidra to decompile from there. Question on Libya?
So I wanted to ask if there are some certifications or like standards for the apps that confirm the adherence to the best practices, and also for developers or architects. Are there some certifications that make sense to do?
That's an excellent question, and that actually motivated a lot of the development of this template that we've generated. So right now, there's no certification process at the moment, and our recommendation is that by developing this application security template that provides a list of best practices that regulators, individual authorities can use this as a template for doing their own assessment. And then, so if you have this list of requirements and best practices, you could go to your application developer, you could go to an independent testing party and say, these are the things we want to test against, and then have them build their assessment based on that. The only other thing that's sort of out there, the GSMA has a code of conduct, but it's fairly high level in terms of what an application should and shouldn't do. There was a code of conduct for mobile money systems, but it doesn't really get into the details of what an app should and shouldn't do. Like I said, there's a best practices document that I hope to co-author, but I think the template goes through most of those things. Now, one of our goals within ITU is actually to develop a security test bed. So Vijay mentioned this yesterday. Hopefully at the next FIGI symposium, we'll be talking about the development of a security lab that will be based here in Geneva, that as a mobile money provider, you can bring your app here and we'll be able to run these assessments and give you some based on the template and give you some details back. But the template is meant for you to be able to use as a starting point for developing a set of requirements that's going to be most relevant for your particular jurisdiction. I think Rehan will talk about the application security framework that was developed by the State Bank of Pakistan. That's a great tangible example of what one of these would look like. It's a question from the right.
Thank you, Kevin. My question is, I haven't read the template, so I'm not so sure whether it covers it. What's the frequency that one should subject an app to this form of testing? Is it whenever there is an update?
Right. If anybody else has a mic on, if you don't mind turning it on. Okay, I was just back from that one. So that's an excellent question, and that's a really good question, and it's one of the things that with general software, we've talked about compliance for the last 20 or 30 years, and figuring out the schedule for how to do it is still problematic. One of the problems with high assurance software is anytime you make a change, if you have to go through a very complicated routine of recertification, then it can be the enemy of innovation, and it can make it hard to do. So I'd say from an assessment standpoint, you should before the application is initially deployed, it's an important time to do a full assessment of the application. If there are updates to the application, then I think it's a good idea to be made aware of what changes are happening in the app. And I think it kind of then depends on the schedule of changes, how often the app itself changes, what the nature of the changes are. If it's changing to a new form of encryption, if the changes are, say, primarily based on the user interface, then the effects on security are relatively minimal. If there are a lot of changes to the back end, then that might be the time when you may want to do a reassessment. But being able to assess quickly, having done sort of a full assessment at the outset means that if somebody patches the application, then the amount of code that's changed should be relatively small, and doing the assessment over that small amount of change code should be much, much faster than doing it over the entire app as a whole. So I'd say that you can do sort of quick assessments before changes to the back end, but then I think that's going to be up to sort of the individual jurisdiction in terms of when a periodic reassessment should happen. Because of the fact that the technologies are changing quickly, the platforms are changing, and the types of services that are being offered are changing, I'd say that whenever any of those major changes are noted, that's a good time. And if something like a major vulnerability occurs based on, say, a vulnerability against the underlying mobile platform or against some of the encryption ciphers that's used, then it's a good time to also be talking to the developer about ensuring that they have defenses put in place for those dealing with those vulnerabilities and having a contingency plan for how to ensure your app is still functional. Question from the back.
Kevin, thanks for the. Okay, thanks for the presentation. So I have a couple of questions. One is regarding the tooling. My personal workflow involves ADB, APK tool, Xtuja, then JDGUI, right? So do you have any different experience using these two different tool sets? And also in the earlier slides you talked about dynamic analysis. I thought you touched on that, maybe using FIDA or PIN or whatever.
Yeah, great. Both excellent. So ADB is particularly useful for ADB is the Android debug bridge, and it allows you access onto the device to see what's going on, to get a lot of insight into the internal state of the device itself. I think those are great tools. I think they're great complementary tools to a static analysis. So what I've described to you here is what's called static analysis, meaning that you're looking at the entirety of the code base. One of the drawbacks of looking only at the source code and not at the application as it runs is that some of this code might not be being used. For example, as we talked about before, you might have code that's designed for different platforms. And so when you actually compile your application, you're going to have code paths. For example, say that you've got code for a fingerprint reader inside your code base, but the app that the platform you're deploying on doesn't have a fingerprint reader, then that code will never be exercised. So you could have the potential for so-called dead code by doing through static analysis alone. So I think it's good to have a dynamic analysis as well. And dynamic analysis is also a good way of validating things that you find in static code. So I think that the use of ADB and the use of dynamic platforms are both excellent and should be considered complementary to source code analysis.
I wanted to ask if the quantum encryption is something that you already take under consideration, or it's too far in the...
Yeah, look, it's an interesting question. Quantum is there are certain algorithms that are, so for example, there are certain algorithms that are being used right now that where if quantum computing was to happen, was to become totally common tomorrow, we'd be fine. For example, hashing algorithms are not reliant. None of the properties that you get from quantum computing are going to make hashing any easier. Hashing is considered to be post-quantum secure. Symmetric cryptography like AES also relies on different types of mathematics or different computational structures than what quantum computing would allow. So AES will still be secure even if quantum computing becomes a thing tomorrow. Where we're going to have problems is with public key encryption, in particular RSA, because RSA relies on the hardness of factoring really, really big integers, 1024, 2048. It's effectively, in computer science speak, it's considered to be in the class NP, so something that's a non-deterministic polynomial time. Now, with quantum computing, where if quantum computing works the way that people say it's going to work, then you'll be able to solve exponential time algorithms in polynomial time. Now, what that means to the layperson is it means that integer factoring will be able to happen in less than the time of the universe. How much time that's going to be is still sort of uncertain, but it means that any of these algorithms that rely on computational problems that are sort of theoretically hard are going to become a lot less hard if quantum computing is a thing. So RSA, which is based on integer factorization, or Diffie-Hellman, which is based on solving the discrete logarithm in a finite field, are both going to be problematic in the quantum case. But other algorithms that we have are going to be still usable. So there's research that's being done in terms of effective public key post-quantum algorithms, but that's still very much a work in progress. So it's something that the cryptography and the security community are very aware of and are thinking towards. But in my opinion, the state of quantum computing is such that we're not going to see major threats to, you're not going to see a quantum computer that has enough qubits to solve RSA in the next couple of years. So we've got a bit of time, even if it's going to be an eventuality. I think we've got time to get it sorted out, and it's definitely something to keep on your radar. Okay. And with that, I'm going to turn it over to Rayhan. So thank you. If you have any questions, by the way, afterwards, please feel free to reach out. You can get my email address from Erlene.
Yes.
And I'm happy to answer questions. So unfortunately, I have to catch a plane, so I've got to run. But thanks for your attention. Thanks for your patience as well. There's a lot of to say about it. Good luck with the remainder, and let's get these. Okay. Thanks for everything.
Thanks, Kevin, and a lot of technical stuff, a lot of which is quite technical for me to understand as well. So, time to step back a little. As a regulator, my objective would be to inform you about the regulatory practices in Pakistan. And when we started developing this framework, I got in touch with ITU and Kevin's team, and they were doing already a technical report on app security and draft assurance, security assurance framework for the mobile apps digital financial services. So we started development of this framework in March this year, and the reason was because, as I said yesterday, we started DFS in 2008 with the issuance of branches banking regulation framework. So earlier it was mostly UCC based, and lately, with the proliferation of cheaper mobile smartphones and cheaper internet 3G, 4G, LTE connectivity, quantum of the users have been shifting to mobile apps. So as we speak today, in Pakistan, more than 45% of mobile phone owners use smartphones and mobile payment apps instead of USSD or feature phones. So we thought it's a good time to come up with a security assurance framework for smartphone payment apps. And the framework is still in draft stages because we are consulting with the industry on a lot of issues, because a regulator is not a standard setting body. They are not technical organizations. They just issue the regulations based on the outcomes where they want to be, the principles for technical assurance and for the compliance with international standards. They can refer the providers to follow certain guidelines like PCI DSS and PADSS, or the standards or technical controls published by organizations like FIGI and ITU. So we start with this is a brief overview for our DFS market in Pakistan. We have a 77% mobile phone density, which is like, and all of them, all the 162 million mobile phone connections are biometrically verified. So we know that a certain mobile phone number belongs to this person. So if somebody goes and starts availing digital financial services on his mobile phone, we know that person is authorized to use this through this biometric ID. So out of these 162 million mobile phone connections, 71 million mobile phone connections are smartphone based or 3G, 4G based. 60% of our population is under the age of 45 years. So that's also a huge boost for the DFS, because the millennials, they don't want to go to the branches and go to the ATMs. They all they want is payment apps, is on the go, tap and pay. So we issued the National Financial Inclusion Strategy in 2015 and National Payment System Strategy with the help of World Bank in 2019. Both these strategies complement each other, and the objective is to create 4 million new jobs by 2025, which would add 77% boost to our national GDP and bring in 263 billion new deposits. This is our DFS market. We have microfinance banks, we have commercial banks, and then we have non-banks also coming up. We issued the regulations for electronic money issuers in April this year. So these regulations allow non-banks to start offering digital financial services, basic payment services, with the help riding on the payments apps. So as of now, we have 11 licensed providers, 12 in fact, which and these are the banks mostly, and 4 of them are owned by our telecom operators, 4 microfinance banks. So they are doing these branchless banking services under SPP, State Bank of Pakistan's approval, and with the help of telcos, they have opened 38 million branchless banking accounts, which means 38 million users are now using USSD or apps of these branchless banking service providers. And in case they don't want to use those apps, or they want to cash in or cash out, they can use 420,000 branchless banking agents. These are the retail GSM agents, where the customers of these DFS services can go to cash into their account or cash out. Then we have conventional banks. They are also offering their own apps. 23 banks are offering their apps, and they have 6 million users signed up so far, and then the number is growing. Then we have EMIs, electronic money issuers. They are mostly in the domain of payment service providers. They are linking your banks with the merchants or with other payment system operators, and we believe that the introduction of EMIs would pave the way for non-banks to come into the payments ecosystem and offer digital financial services to the underserved or unbanked segments of the society. It's not working. Please. Okay, so this is the DFS ecosystem, DFS stakeholders, various stakeholders involved. At the bottom of the pyramid is the user of the DFS, and then The DFS services are riding on mobile network operators delivery channels, and then there are DFS providers. They can be banks, they can be e-money operators, then there are retail agents, then banking regulators or payment regulators, and in our case we are also the payment regulator and the bank regulator, then the telecom regulators, then ID authorities. We have a very robust ID authority in Pakistan, National Database and Registration Authority, which keeps track of the citizens by obtaining their multi-biometrics, and then there are third-party service providers which provide the technical capacity to the DFS providers and to enable this whole DFS ecosystem by providing apps, and this includes developers and the technology service providers as well. So as a regulator, I cannot regulate all of these entities. I cannot come up with a regulation which is applicable to all of these entities, because by law I am only authorized to regulate the licensed banking service providers or the payment service providers. So what I do is but my objective is to protect the whole value chain of the DFS, from the user till these technology service providers and retail agents and telecom service providers. So what I do, as a regulator, I would put the onus on the banks, the app providers who are providing those apps. I'm making them liable for the security of the users, of the channel, of the apps. As a regulator, this is my objective. And from the infrastructure point of view, we have very interesting ingredients in place. The whole DFS ecosystem in Pakistan rides on this biometric digital ID. As I said earlier, this is authority under our Home Ministry in Pakistan, which registers every citizen of Pakistan with a national ID number. They issue the ID cards, national ID cards, computerized machine readable cards, and they assign a unique national ID number to every citizen. Once you are 18 years of age, which is a legal adult age in Pakistan, you get this ID card, and then your biometrics are stored in the system centrally, and those biometrics and your unique ID number is required to get you a mobile SIM, to open your bank account, and by regulations we have mandated that for the activation of alternate delivery channels like internet banking or mobile payment apps, this ID will also be used. And then for the branches banking service providers which are doing the OTC P2P transfers, we have mandated in the light of FATF guidance that the sender and the receiver of the OTC payments, domestic remittances, would need to be biometrically verified at each end. So how it works, the retail agents, 420,000 retail agents I talked about earlier, and the banks with 13,000 branches, they all have biometric machines which read your fingerprint, which they communicate with the ID authority, and they confirm that the person who is claiming to be is the genuine person. It's also a proof of life to offer these services and activate these services. So the app security framework, as I said, it's not if we start choosing technology, a certain technology, we would not be able to keep pace with the technology development, because technology sometimes changes overnight. So what, as a best practice, what we can do is prescribe the principles without being too prescriptive, and then let the market evolve. So this app security framework would be applicable to all banks which are doing apps or which intend to do the apps, and these branches banking service providers, the EMIs, the payment service providers. These all are HVP regulated entities. So they have to comply with the requirements of this framework once it is issued. Specifically, it targets the smartphone-based mobile apps, and it covers the whole mobile app ecosystem involving the capturing of customer data, the storing, processing, and transmitting financial and non-financial information. And this whole ecosystem has to be compliant with this framework. And it does not only include the apps or the systems, it involves the people, processes, infrastructure, including mobile apps, the client apps, the web services, the channels, server-side databases, storage and network communications, etc. What are the outcomes? Why we needed to come up with this framework? Because as I said, because there are the different stakeholders involved. The objective was to strengthen the internal control environment in the SPP regulated entities. That is, if some bank or some regulated entity wants to venture into mobile apps, it's a whole lot of new business. You need people, you need processes, you need infrastructure to offer these services, digital financial services through apps. So we wanted the banks, the regulated entities, to have infrastructure in place, to have internal controls in place before offering these services. For this purpose, this app security framework, it's a work in progress. But before that, we have issued an enterprise technology governance framework for banks, which sets out the guidelines for the banks to how to do the basic IT. As an institution, as an enterprise, they have to comply with. They have to have policies in place, information security policies, IT service delivery and operation management policies. They have to classify the information. They get their systems audited and penetration testing in place. So once they have done this basic IT is right. The next phase is they can start offering these DFS services. Then the other objective is the outcome of this framework is to secure the regulated entities arrangement with third parties, as a lot of third parties are involved, which are not regulated by State Bank, but by virtue of being a regulator of the banks, we can put the onus on the banks to secure their arrangement with third parties. Another intended outcome of this app security framework is to encourage the banks to adopt global industry best practices, including PCI DSS or PADSS, tokenization standards by the payment schemes as well. And then at the end, the objective is also to increase customer awareness, because most of the frauds we have seen in Pakistan lately relate to the lack of customer awareness. We had census in 2007, national census in 2017, and where then the census authorities went door to door to count people. And after that, we have seen a surge in social engineering frauds related to these use of these apps. Somebody would receive a call from pretending to be a national law enforcement agencies or census authorities, and they're telling people to share their passwords or share their account numbers with them, and then stealing the money from unsuspecting customers. We've seen a lot of surge in these type kind of frauds after the census. Then we started a campaign to educate the customers. The banks, the regulators, the law enforcement agencies, they would never ask your personal credentials or banking credentials. So this app security framework also intends to address those gaps. So this is applicable on the whole value chain, from the architecture to the design, development, and deployment of mobile apps. App owners are because our addressees are banks or regulated entities. So we call them app owners. They maybe they are getting their apps developed by some third-party developers. Maybe they are developing those apps in-house, or maybe they are purchasing off-the-shelf apps. But at the end of the day, our target audience is the app owners, which are regulated by us. Once they have purchased or get those apps developed by third-party developers, they are now the owners. So they have to ensure that those apps are in conformance and compliance with the regulatory requirements. So they are required to ensure that the requirements of these frameworks are transmitted to the developers, to the architectures, to the testers, and to the security professionals and consumers, so that the whole value chain is at the same page. So the responsibility of sharing this app security framework and heading to the principles of this framework lies with the app owners. So as Kevin said, there are a lot of we didn't need to reinvent the wheel for developing this framework. A lot of groundwork has already been done by standard setting bodies, and if you have been following some of them, like Open Web Application Security Project, they publish major vulnerabilities, app vulnerabilities annually, and these some of the vulnerabilities we have highlighted here, which is weak server-side controls, insecure data storage by the apps, insufficient transport layer protection, as Kevin discussed in detail regarding the adoption of TLS, and unintended data leakage, weak authorization and authentications, and then poor session handling. Some of these vulnerabilities exist in the apps if they are not following certain standards. So our app security framework addresses these major vulnerabilities. These are the security dimensions, and ITO's X.805 is a good starting point to know which security dimensions are needs to be addressed when you are developing a framework for the for the DFS providers. You have to give them the guidelines, or you want to ensure that the apps or their DFS systems address these security dimensions like access control, authentication, CIA triage, confidentiality, integrity, and availability, non-repudiation, and communication security. So if you look closely, these security dimensions relate to these vulnerabilities. So there is a relationship here. So what we are trying to do, we are trying to address these vulnerabilities by addressing these security dimensions. So if you read that, there's a very interesting report which Kevin discussed yesterday and today as well. So they have these 160 plus controls, very technical, very ground level controls for in these security dimensions, in X805 security dimensions. So what we can do, because this this FIGI report addresses the whole value chain, like they address the controls which needs to be placed at the user, the controls which needs to be placed put in place by MNOs and by banks, by third parties, by merchants. What you can do is you can pick and choose those controls. If certain controls may be applicable to your regulated authorities, entities, some of them may not be regulated. So it's not a one size fits all. You can pick and choose. So as I said, we started the development of this framework in March this year, and then we shared our frame. ITU was incidentally ITU FIGI was also doing this report in the similar time. So we shared our framework with them for their feedback, and they said they're already working on a report on DFS security assurance framework. So we held back. So we thought we might be able to learn something new from their DFS security assurance framework. And the dimensions, as I said, the security dimensions we have addressed pertain to X805 security architecture for systems providing end-to-end communications, 8 security dimensions which are addressed in our app security framework. Then Open Web Application Security Project and National Information Assurance Partnership. It's protection profile for application software. It's a very extensive document. It's based on the common criteria which is used by national governments, national agencies, law enforcement agencies, and technical bodies to vet the security of applications, software applications used by the governments. So it's a very extensive, very elaborate kind of document protection profile for application software. I would highly recommend if you are interested in knowing the basics of how to vet the security of the apps. This is one of the document you would like to go. And then there is national NIST 800 special publication 863, which is also vetting the security vetting the security of mobile applications. That's also an interesting document. So these are the security requirements, the 8 domains which we are trying to address through this framework, and we have laid down the principles, a few principles for the DFS providers or the app owners to follow when designing or deploying their payment apps. We will most of these controls have already been discussed in detail technically by Kevin. Uh, uh, Again, the focus here is for the regulator is not to be too prescriptive and to recommend a particular technology. The regulations which you are issuing as a regulator have to be technology agnostic, so that even if the technology changes, if TLS 1.2 or TLS, when before TLS there was SSL, so everything was based on SSL. So if a regulator is prescribing, okay, TLS 1.2, maybe it's the TLS 1.3 is coming, and you have to then amend your regulations as well to recommend TLS 1.3 now. So instead of specifying what technologies or what versions of technologies you need to use, I think it's better left to the standard setting bodies or technical bodies, and all you can do is you can refer your regulated entities to those particular standards or technical controls instead of specifying them for yourself. So we will discuss authentication and authorization requirements, network security requirements, input output handling, tampering detection, protection of sensitive data, and secure coding practices, and again this has been repeated here. And then they have logs and data leakages. So just to give you a basic flavor, we I think no regular in Europe they are trying to do in this red team testing frameworks. They are developing this threat intelligence based red teaming frameworks, which we discussed yesterday. The CRO methodology, the operationalization of CPMA ISO framework for the checking compliance of the regulated entities with the framework. But at State Bank, we do not have that technical capacity. We have on-site teams in the inspection departments. They go to the regulated entities premises. They check their manuals. They check. They sometimes they do mystery shopping, and they try to find the vulnerabilities and weaknesses, and then point out to the banks on to correct those. But we are thinking on the lines of having a panel of certified testers, so that we can recommend the banks to use the services of those testing agencies, testing entities to test their DFS apps and DFS systems. And just like we have a panel of auditors which we prescribe for the financial audit of the banks, when we are going to audit their statements, we are thinking on the lines of having a panel of penetration testers, or so that we can recommend the banks. If you come up with an app, you get those apps tested by those testing authorities. Okay, so in this authentication and authorization domain, there are certain controls which we are recommending. Again, technology neutral. We are requiring that once a user downloads an app on his device, the app should be tagged with that particular device and with the customer's account. So what happens? So when we put in this condition and we shared this with our industry for the feedback, there were comments that this would hamper the user experience, because if I have an app tagged with my device with device binding functionality, maybe I would not be able to use the app on some other phone. But this is one of the mechanism for step-up authentication. It's a passive contextual authentication, if they call it. the app fingerprint, app biometric is also being device fingerprint is also being used to identify that the person who is trying to communicate with the server is the person who has downloaded this app on his device, and his account is tagged with that device. Then we have this biometric based activation. This came up with in response to a major security breach in one of our banks last year, where the bank lost $7 million overnight in a man-in-the-middle type of attack. So we came up with the advice of our law enforcement agencies, because we have this biometric database of all citizens. So we wanted to utilize that, and now we have made mandatory for the banks, so that whenever a customer requests to activate his internet banking or mobile app banking, mobile apps, you have to biometrically verify him. Either you can call him into the branch, you can send your staff to the customer's location to get his biometrics verified before the activation, or you can. So our 14,000 ATMs are also biometric enabled ATMs, so the customers can go to the ATM machines of their bank and get themselves biometrically verified before the activation of these apps. So this acts as a what do you call this, strong customer authentication, because if customer is consenting for the activation of ADC or app, the bank is responsible to first verify that the person who is requesting the activation of such services is the person who he wants to be, who he claims to be. Then we have this separate login authentication and transaction authentication mechanism. This means that once you're logged into your app and you are doing a financial transaction, you are doing a payment transaction or fund transfer transaction above a certain threshold, maybe above $1,500, if you're trying to pay or transfer $1,500 or above, you would again be required to authorize the transaction by entering maybe an OTP or by authenticating the app through your biometric. So this requirement came up when we heard of a security breach in one of the apps, 7-Eleven apps, which was crashed in Japan last year. So what they did is they did not require this transaction authentication. There were no limits on the payments, so they lost almost 70 million yens overnight, because of there was no requirement, there were no limits, and there were no requirements to authorize the transactions above a certain threshold. So what we are requiring the banks is above a certain threshold, they would require another factor of authentication before authorizing those transactions. Then we have this requirement of multi-factor authentication before the activation of app. The biometrics, the device biometrics, the retina scan, the OTPs, the passwords, all of them, and this device binding is also a step-up authentication mechanism. This also acts as a multi-factor authentication. Something you have and something you know, and something you are is the biometric. Then we are requiring the banks, the regulated entities, to have strong configurable access codes like pins, passwords, biometric in place from the server side. And then we have a requirement that the OTPs shall be valid for a strictly minimum period. So when you get an OTP on your SMS, so the expiry time would be defined by the bank. We are not prescribing any particular time, but we are requiring, as a principle, we are requiring that the validity period of that OTP shall be minimum. Then we have the requirement of idle session termination. Again, we are not giving any timelines here. Maybe a session, if it's idle for like 15 minutes, it automatically logs off. So this again is left to the regulated entities to define those time windows which would expire the session. Then this is all a repetition of what Kevin did earlier, but he did it in detail and at the technical level. What we are doing here is without specifying specific technologies or the techniques or methodologies, we are giving the principles to the regulated entities to do these security activities on their apps. PCI DSS, when we because our app security framework is still in a draft stage. So when we recommended that whenever your app is some bank's app is capturing customers' card data, payment card data, so the allied infrastructure, the backend servers, the payment apps, they have to be PCI DSS certified. So there was a strong resistance from the industry, because PCI DSS has huge costs. So this for the small players, microfinance banks, mobile who are using the mobile financial services as a basic necessity for extending the services, PCI DSS is not feasible. So we are now thinking to withdraw this requirement of PCI DSS certification. Instead, the banks or the schemes are proposing that they can come up with tokenization solutions, which reduces the cost of PCI DSS compliance. Then we are requiring that sensitive information like passwords or pins cannot be stored on the mobile devices. We are requiring the regulated entities to use industry standard cryptography encryptions, like as we learned that a lot of cipher suits are no more compatible with new technologies like AES. They are no more recommended to be used in this. So the developer should know what cryptographic standards they are trying to use in those apps. And then encryption of the sensitive data in transit and at rest. Then sensitive data shall not be transmitted through vulnerable channels. This is a requirement which tries to address the SS7 vulnerabilities. If you are transmitting passwords or sensitive card information with personally identifiable information through SMS, through USSD, it's not advisable. It's better to be shared through a secure channel. How the regulatory entities are going to do it, we don't know. Then in the network security domain, we discussed TLS in detail, transport layer encryption for all communications between the mobile app and the server. So then the app shall have inbuilt controls to mitigate bypassing of certificate pinning. And then the certification errors, if app when communicates to the backend server and there are certification errors, maybe the certificate is expired or the validity period is expired, and then what developers can do is they can enable the apps to ignore those certification errors. So we are requiring the regulatory entities that the app shall be developed in such a way that certification errors shall not be ignored. If there are certification errors, the app shall not be allowed to communicate with the backend server. And then the basic requirements is that certificates shall not be self-signed. They shall self-issued. They should be issued by trusted certificate authorities. On session management, we are again, as discussed earlier, we are specifying that after a certain time, certain idle time, which should be configurable by the developers, the app shall automatically log off. Then easy to use and clearly visible log off method. We are also advising the regulatory entities to disable access to mobile app server from devices which are reported stolen or lost. So if your device is lost or stolen, so you have to report that, just like your credit card, you have to report this to your bank that your device is stolen. So that bank can mark this device in their servers as stolen and disable the access to their server through those devices. So there has to be a policy in place, a mechanism in place for the customer to communicate to the bank that his device is lost or stolen, so that bank can disable the access. Then we are requiring the banks to detect multiple simultaneous login attempts and communicate to the user. So at a certain time, and then yesterday we had a question that why we are requiring the geolocation access. So what we are doing here is we are requiring the banks to develop apps in such a way the functionality has to be there, that if a same customer is logging in from like Geneva and Karachi at the same time, that's a red flag. That should be flagged. So because how can I be in both the locations and I'm logging into my applications from Karachi as well and from Geneva as well. So that's the red flag for the should be the red flag for the regulated entities. Tampering detection. So when you launch an app on your mobile phone, it would do some basic integrity checks before linking it with the server to detect any manipulations, because this addresses the security of your device. There are number of apps, maybe some of the rogue apps on your device, and through in-app inter-process communication they inject some malicious code into your device. Or so whenever you launch your application, there would be some integrity checks which would be required by the server side to allow access to communicate it to the server. And then the basic requirements again is the apps shall have the functionality to detect if the device they are being downloaded to and installed, they are not rooted or jailbroken. So if they are rooted or jailbroken, the app would not install. Because if a device is rooted or jailbroken, we cannot be assured that about the security of that particular device. So once maybe there is debugger or emulator running on the device, so the app should detect those the debugger and emulator, because then to know that if it's being debugged or emulated. And then there is a requirement of secure coding, and there are a lot of standards in place of secure coding best practices. We are requiring that the app owners, in fact, require their developers to adhere to the industry accepted secure coding best practices and standards, avoid vulnerable deprecate components, protocols, and libraries as standard practice. And then code signing shall be used for mobile apps, so that you can be sure that the code developed by the certain developer is for that particular regulated entity. Then input and output data handling. Data has to be sanitized and validated to avoid if it's talking to some databases at the back end, to avoid SQL injection. So autocomplete feature, we are also requiring the app owners to disable the autocomplete feature for sensitive information. You have to enter your credit card number or your beneficiary account number every time. You do not just have to copy and paste those functions. Then for the regulators, it's very interesting domain is logs and data leakage to reconstruct the audit trail for the audit. Mobile app logs shall not contain any sensitive data, because logs are accessible to a number of participants in the system. So log servers shall be segregated from application servers, and we are requiring the regulator to protect the logs from unauthorized modification or destruction. Then audit logs shall be maintained at the server level. The app shall not store any audit logs, because there might be some certain information in those logs to reconstruct the customer credentials. Then there is a legal requirement to retain those logs for a period of 5 years at minimum, so that for the regulators and for the law enforcement authorities to for their audit purposes. And then then this is an requirement which pertains to user awareness, and also pertains to protect the apps integrity of the apps. So the apps we are requiring that app has to be hosted only on the relevant platform of such as Google's Play Store or iOS App Store. The app shall not be hosted at the app owner's website. As if Bank ABC is hosting its app on its own website, that's not advisable. We are prohibiting the banks to host to use this, because if your websites if your website is infected, the app can also get infected. So your apps are required to be hosted on the relevant platforms. And then we are requiring the banks to ensure that all users are informed that their apps are only stored on the relevant platforms, not on any other website or the developer's website. So if somebody claims that you can download ABC Bank's website mobile app from their website, that must be brought to the notice of the customers that this is not a true original app of, or maybe it's a cloned app. So this is also the responsibility of the regulatory entities to ensure that their apps are not stored are not available for download from unauthorized websites. So it's easier to put in regulatory requirements and prescribe certain standards, but it's an whole different ball game to assess compliance. So for my in my experience, regulators, it's very easy to issue regulations, and maybe to some extent the regulatory entities also comply with those regulations. But how the regulators would assess the compliance? So in my experience, we are reliant on third parties. We are reliant on the testers of the bank's own internal audit and other standard setting bodies. So there was a question earlier here from Samuel, I think, where you were asking Kevin to about the frequency of the tests or audits for those apps. So not in this framework, but in our enterprise technology governance framework, we have mandated that banks or the regulated entities by SBP has to get the systems pen tested and scanned for vulnerabilities every year. The frequency is every year, but with the if there is any change in technology, underlying technology, the change in platforms, the addition of new features, then they have to be tested as well. When and where, as and when there is a change in the systems or underlying technologies. The best thing is to test try to test those do your apps after the production, before after development, before deploying those in the real time. So once you are developed the apps, you should we are requiring the banks to get those apps tested and then deploy in the production environment. So we have made it mandatory penetration testing for mobile apps and their backend ecosystems, and we have mandated the periodic vulnerability scans by the banks themselves and by third parties. So what they do, they get those apps tested and scanned through some third parties, and they submit those reports to us with full disclosure. And then if there are any vulnerabilities, we advise the banks to address those vulnerabilities in certain time period, or to stop certain functions of those applications until and unless those vulnerabilities are not addressed. But going forward, we also want to have this capacity to go and check the compliance of our regulatory requirements. So we are working with World Bank, we are working with ITU and FIGI to adopt this operationalization strategy for cyber resilience of FMIs, which is like cyber resilience oversight expectations, where you would be able, as a regulator, you would be able as an overseer to grade the FMIs in your market as mature, as innovating, or as compliant. So we are trying to adopt this strategy for this DFS ecosystem as well. This is an area we are struggling right now, and we are trying to learn from the standard setting bodies.
Yeah, my question is there a minimum threshold that below which you would then recommend that the app is put out of service? And also, if there are material vulnerabilities, is there a window provided for the app owners to close those gaps? Because I had you mention, like, on password transmission through SMS, that you don't know how they do it, but you demand it.
So yes, as I said, we had a major cybersecurity incident last year in October, and after that we came up with Payment System Directive number 9, where we mandated those pen testing and vulnerability scans, and we required the banks to submit those reports to us within 3 months. And I don't know of any incident where we require the banks or a regulated entity to shut down those apps or systems. I don't know any of these instructions, but yes, we do give some timelines to the banks to rectify the errors, rectify the weaknesses, vulnerabilities identified in those reports.
So it is subjective.
It is subjective.
It's
yes.
not.
Okay. It is subjective. Any other questions? So if we don't have any questions, I think that's it from my side. Any comments?
I wanted to know whether you've talked of third parties doing the assessment compliance, and I believe there's a whole pool of third party companies who do or deal with the same issue. Do you have recommended and the ones who have the best practices in the market, or how do you do it? And how do you get the reports to make sure they are not tampered or they are not manipulated, whether it's the side of cybersecurity or it's on the ledger books?
Okay. Yes. So for the financial audit, yes, as a regulator we maintain a list of auditors, which banks are required to pick one of those auditors which from our list. But for this penetration testing and scanning requirements, because this is a new area, so there are not a number of players in Pakistan. For banks, it's very costly to hire some international penetration testing bodies like maybe Mandiant or FireEye. So they have to rely on the local organizations. We have maybe 3 or 4 such organizations which are doing these services in Pakistan, but we do not maintain a repository of those. We have to rely on those reports. Yes, but yes, we do try to ensure that those reports are not just fulfilling the requirements, just checking in the box. Sometimes we have observed this tendency that banks tend to submit those reports just as a compliance requirements without going into the depth in details. But we do not have any other way to ensure that those reports are not faked, because we lack the technical capacity. But what we are trying to do is, going forward, we would put in a code of conduct agreed with the banking association, that when they hire a certain tester, These are the code of conducts which they have to follow.
Maybe something related. In Uganda, the AML regulator has to approve the assessor or auditor before they commence work. So something similar can be adopted for the testing or security assessment.
Yeah, valid point. So we had this global CISO coming into State Bank a couple of months back, and we were discussing about assessing the PCI DSS compliance requirements for banks. And he's working in some African country. I don't know which country he talked about. And he said that the QAs, the PCI DSS quality assessors, even they are hand in glove with some of the banks when they are trying to submit the PCI DSS compliance reports to the organization. They just do whatever the banks want them to do. So it's quite messy over there. But we have to rely on those reports for the time being.
I was just wondering, what roles does the telecom regulator play in Pakistan in securing digital financial system?
Right. So, as I said earlier, yesterday, we have a very very cooperative telecom regulator. We have signed an MOU with them back in 2011, I think, whereby we advise them on how to regulate the telecom part of the DFS. So they also issue certain regulations to the telecom companies, mobile network operators, and one of them is like the mandatory biometric obtaining of biometric every time a SIM is issued or reissued. So, but other than that, they are cooperative. They listen to us. Yes, sir. Please.
Yes, just quick question. I know you touched briefly on the hosting of the application. I just want to know if there are any restrictions in terms of where the data can be hosted. Specifically, what I mean, if the data can be hosted in cloud servers outside of Pakistan.
So, in terms of cloud, yes, we have this regulation which came up in 2017, and we do not allow the offshore storage of data on clouds. But for going forward, we are going to look into this, because for the payment apps, the non-banks which we have just allowed to come up with EMI business, electronic money business, they would their business would greatly rely on the cloud services. So we are looking to allow the offshore cloud hosting for the payment service businesses. For banks, it's not allowed.
With regards to banks moving their services or offering services on the cloud, I would like to know what your opinion is, especially in Pakistan, with regards to banks hosting applications on the cloud from a security standpoint.
Okay. So, in terms of cloud, yes, we are clear that if your data, there is strong competing narratives on regarding the security on cloud. So we think banks always try to lobby that it's easier, it's cheaper for them to use the cloud services. But the regulator, when we are developing a policy, we have to consult the government, we have to consult the law enforcement agencies. So there is a tendency to think that once your data is out of your geographical boundaries, you lose control on that. So right now, we do not allow the banks to host their applications or customer data on offshore clouds. But within country, if the cloud service provider is located within the country, then it's okay.
I, however, think that's so much against innovation at scale. So what some markets have done is they insist on a local copy, a local instance, but not necessarily to say you can't host data out, because multinationals take advantage of scale in cloud hosting. Some of these global cloud services are way better than the in-country services, so you probably want to reconsider.
Yeah, we are actually. We are going to reconsider it. And just as an example, there is this growing tendency to again this what do you call data residency requirements across the globe, specifically in our region. So the Reserve Bank of India last year they asked all the payment service providers, including the payment schemes, Mastercard and Visa, to bring in every transaction data within the country within 24 hours. So no, the transaction can happen outside the country, but the data has to be reside within the geographic boundaries of India within the 24 hours, and the external copies which are stored outside the country has to be destroyed. So this data residency is a new challenge for us, but yes, from enabling innovations point of view, we are looking into allowing allowing the offshoring of cloud services with certain requirements, like maybe you cannot store personally identifiable information PII outside the country, but for transactional data, if it's encrypted, yes, I think we can allow the clouds. So I think we are done. No more questions.